Right along factoring quadratics. Here's what we've done so far, just as a reminder. We've introduced what a quadratic is, and remember this is the general form for a quadratic, ax squared plus bx plus c, where a, b, and c are just integer numbers. Those numbers are actually called coefficients. Here a, b, and c are called coefficients. And then we solved one. We actually went through the process of foiling one, doing it backwards so that you could see exactly how to unfoil, and unfoiling is factoring. Unfoiling is just another word for factoring, and when we factor, remember, we're unfoiling. And then we also talked about how the answers to these values for x that make this equation, make this quadratic equal to 0, have three names, and those names are solutions, roots, and zeros. And zeros should make sense to you. Why are they called zeros? Because they are what I can plug into this quadratic that will make this quadratic equal to 0. And so we're going to continue along, and all this lesson is we're going to be practicing different examples that are a little bit more difficult. So let's just continue right along here. Okay, now you will notice that this looks very similar to this, except the signs are a little bit different. Here we're adding. It's x squared plus 5x plus 6 equals 0. Here it's x squared minus 5x plus 6 equals 0. So now we're not just working with the factors of 6 to get positive 5 like we were here. We're working with the factors of 6 to get negative 5. So obviously when we factor this, we know it's going to look like this. And that's still going to equal 0. And we know that this is going to be x, and this is going to be x, and we know that this is going to be 3, and this is going to be 3. Okay, so now we want to, oh, I'm sorry, I misspoke. This is going to be 2. Now we want to work with the factors of 6 to get positive 6, so we need to be multiplying two things that get positive 6. How could we use 3 and 2? What are all the different ways we could multiply 3 and 2 to get positive 6? Well, obviously positive 3 times positive 2 equals 6. But also, the other way to get that is negative 3 times negative 2 equals positive 6. So those are the two ways we could multiply these factors to get positive 6, but we need them to add to negative 5. Okay, so here are our two options, positive 3 and positive 2, and negative 3 and negative 2. Which one of these, when I add them together, are going to give me negative 5? Clearly the answer is negative 3 and negative 2. Negative 3 plus negative 2 will equal negative 5. So here, both of these need to be negative. Okay, and so that's how we do that. A minus first with a plus here. When this is minus and this is plus, these two will always be negative when I factor. That's the easy way to remember that. Now what we need to do is, what if it was another example, and I'm actually just going to write this out here. What if this time it was x squared minus 5x minus 6 equals 0? How would I factor that? Really quickly before we move on to this example, I want to come back to this one for just a second. Remember, if we were solving this, if the instructions were solve by factoring, we would get here, and then we would need to set both x minus 3 and x minus 2 equal to 0 in order to solve it. Remember, when you are solving, it's asking you for solutions, roots, zeros. So you would need to have two number answers that say x equals this and x equals that. So just remember when it's solving. So we didn't do that here. We didn't go the full way and solve it, but you could very easily set x minus 3 equal to 0, set x minus 2 equal to 0, and solve. So I just wanted to make that point before moving on. But back to this example. Okay, so when we're factoring, obviously, always when we're factoring, we know it's going to look like the multiplication of two linear expressions. This is going to be x, this is going to be x. Okay, now I have to work with the factors of negative 6 to add to negative 5. So what factors of negative 6 will allow me to add to negative 5? Well, what are some factors of negative 6? Okay, well, we obviously know we're going to be working with 3 and 2. It can be negative 3 and 2. and that would give me -6. But when I add -3 to 2, that doesn't give me -5. There's no way I could add -3 and 2 to give me -5. Well, what about 3 and -2? Well, clearly that, when I multiply them, equals -6. But just look at this. Once again, if I were to add these two numbers, these two factors, there's no way that I could get them to equal -5. So clearly the factors of 6, none of these factors are what will allow me to to factor this quadratic. And so I need to rethink this. So I'm going to erase this here. Can you think of any other factors of -6? And hopefully you're saying to yourself, yes. What about -6 and 1? -6 times 1, that does equal -6. When I add these two together, what do I get? -6 plus 1, that is -5. So these are the factors that we're going to be using here to literally factor this quadratic. So it doesn't really matter what order I put them in. Here's -6. This one has to be +1. And that still equals 0. If I were solving this, let's say the instruction said solve this, then I would need to set x minus 6 equal to 0. And clearly to get x by itself, I'm going to be adding 6 to both sides, and I would get x equals 6. And then here I would need to set x plus 1 equal to 0. And then I would need to subtract 1 from both sides to get x by itself, and this would be x equals -1. Okay, so x equals 6 and x equals -1 are the solutions to this. They are what I could plug into this quadratic that would make this quadratic equal to 0. Okay, so we're going to do one more example. And what if it's not a quadratic? Okay, what if it's just an expression? What if it's just an expression that doesn't have 3 terms, doesn't have an a, b, and c? Can I still factor this? And the answer to that question is yes. When you see ones that look like this, you need to look for a greatest common factor between these two terms. When I say greatest common factor, what do I mean? I mean, there are factors of 12 and there are factors of 18. And if these two numbers, these two terms, share any factors, then I can factor that out. So clearly the number 6 goes both into 12 and into 18. Let's write this out. So if I were to break this apart into its factors, I could rewrite this term right here, 12x to the third, like this. Here's how I'd write it out. 6 times 2 times x 3 times. X to the third. Oh, oops. My mouse messed up here. X to the third means x times x times x, right? So if I were writing this out in terms of its factors, this is what it would look like. And then here with this one, there's still a minus. And then if I were writing out the factors of 18, one way that I could do that is 6 times 3 times x, because it's only x squared, so I'm multiplying x twice. So that is how I could write the factors of 18x squared if I wanted to. There's lots of ways that I could have written this. I could have chose 4 and 3 here. I could have chose 9 and 2, but I chose these for a reason. And when these two terms share a factor, that is called a greatest common factor. So what all of these factors do they share? Where clearly they both have a 6. There's one here and there's one here, so that's a common factor. And then there are 2 x's in each of these terms. So overall, I can take out a 6x squared of each of these terms. And what's left over? Well, I need to put that in parentheses. What's left over here is 2 times x. And what's left over here is just this 3. So when I take the greatest common factor out of both of these terms, this is what factoring looks like. And then still I would need to break this apart and set each of them equal to 0. So 6x squared equals 0. And 2x minus 3 equals 0. And when I solve each of these expressions, I will find out exactly what what I could plug in here to give me 0. This one, just trust me, you could do the math and you would get that here x is 0. And once again here, you could do the math here, and this would give you x equals positive 3/2. And just trust me on that. You will get plenty of practice doing quadratics, I promise. Okay, so there you have it. Those are some a little bit more complicated examples of factoring quadratics. What we're going to do now is we're going to have plenty of practice problems, and we're going to, in fact, walk you through how to do some even more complicated examples.